Hey everyone, I'm Pragati from the Robotics Club of AIT. So this is the second part to the video how to code in Arduino. And if you haven't watched the first part, I have left the link in the description below. Previously, we had learned about the three main parts in any Arduino code, that is the structure, values, and functions. In this video, we are going to learn more about how you can code in Arduino using operators, conditional statements, and loops. I have used the previous code that we had made in the last video, and the source code for that I have mentioned that in the description below. So let's get started. Now let's try a variation in this code. Let's have this interval, that is your delay time period, to change every time the loop runs. So for that, I'll first have to initialize a new variable called as time interval, and that I'll equate it to 100. And instead of this 100 that we have used over here, 100 milliseconds, I'm going to put the time interval value. Now I want this to change each time. So how do I want it to change? I want it to go from 0 to 500 and with a step size of 100, and then I want it to decrement from 500 to 0 with again a step size of 100. Now both of these can be done by first understanding that you'll need to change the direction at the peak values. So for that, let's create another variable int dir1, one for the positive side and -1 for the negative side. The direction is going to change each time, so let's create a function for it. So let's have the function return the direction value. So direction is an integer and we're returning an integer value, so I'm going to go with int, then your function name, that is change direction, and then goes in the argument list. So the arguments that we're going to give in here are the direction and the time interval. So what exactly the syntax basically is, you have the return type, you have the function name, and then you have your list of arguments plus the data type. But when you're calling the function over here, say I'm equating direction equal to change direction, and then you pass in the arguments. So in this case, you do not give the data type as well. So it's just plain dir and time interval that I'm sending. Now the values that you have over here are going to have a one-to-one correspondence to these values. You can change the variable names over here, it doesn't matter, but make sure you use these variable names only in the function body. So now let's start off with the function body. What we'll be doing here is changing the direction each time it reaches the peak value. So I'm going to check if it's reached the peak value first. For that, I'm going to use a conditional statement, and I'm going to check if my time interval has reached its maximum, that's 500, or if it's reached its minimum, that is 0. Then in either of these cases, I want to change the direction. For that, I am going to again give if statement. So if my direction value is greater than 0, that is if it's moving in the positive direction, and if it's reached the maximum, it's obvious that it's reached the maximum if it's moving in the positive direction, I'm going to change it to -1. And if its direction is less than 0, that is negative, then I'm going to change that to +1. So because this is the exact opposite of this, I can use an else statement, ignoring the fact that there is an equal to 0 as well, because we are not having that value getting in direction anywhere. So it's just going to be greater than 0 or less than 0. So that's why I would directly use an else statement. So it's if the condition is satisfied, the body of the else statement, if statement gets executed. Otherwise, the body of the else statement gets executed. Now, because we have a return type of integer, I'm also going to return the direction variable, and that's what's going to get stored here. Now, as soon as I change my direction or have the same direction itself, what I'm going to do, I'm going to change the time interval value. So my time interval, if I write it in shorthand, plus equal to direction into 100. This basically means that I have time interval equal to time interval plus direction into 100. So now I also want to view the time interval each time the loop gets executed. For that, I'm going to print it in the serial monitor. So serial dot print. This is for printing it in the same line. So any next time it's going to print, the same line again. But I do not want that, so I'm going to do serial dot print ln, which means it puts a backslash n each time this piece of code gets executed. So over here, I'm going to display the time interval, and this should do. This is enough. Now, there is a small error, a glitch that you'll find. Each time the loop is going to run, it's going to assign the time interval value again to 100. And this is going to keep happening. So your final value that's going to get outputted each time is going to be 200, which is not what we want. We want it to increase and then decrease. So for that, we are going to add a static keyword before this and this, which means that just initialize this to 101 for the first loop. For the rest of them, carry forward with the values that was already present in them. So this does our code. Now we'll go upload it and see how it shows up in our Arduino board. So now that we have seen how our code works, let's go on and understand the operators that we have used. So operators can be divided into five main categories: arithmetic, comparison, Boolean, bitwise, and compound. Arithmetic operators are plus, minus, multiplication, division, equals, and the last one, that's modulo, basically gives us the remainder. Comparison operators are those which are mainly used in conditions of if-else statements and while loops. Boolean operators are those which would check the truth value of its operands, and based on that, it would check the truth value corresponding post operand's truth value in its truth table, and accordingly give us the final output. So this one's just going to negate. That's give a false if our operand is true and true if it's false. This is the OR operator and this is the AND operator. Bitwise operators work as the name suggests. Bitwise. So what exactly it does is, say for example, I have 2 ampersand 3. It's going to convert each of them to bits. So basically binary. So 2 is going to get converted to 1 0 and 3 is going to get converted to 1 1. Then it's going to use its AND property and check 0 and 1 is going to give us 0, and 1 and 1 is going to give us 1. So final output is 1 0, and then it's going to convert that back to decimal and give us the value of 2. So 2 and 3 will result in. So similarly, you have your OR operator. This is the XOR operator. Then you have your negation, which basically means if I do like negation 2, what this is going to do is 0. It's going to make it as 0 1. So your output will become 1. And then you have your right shift and left shift operators. What they do, so left shift operator is going to shift your decimal point to the right, in this case the binary point to the right, and your right shift operator is going to shift your binary point to the left. So by the number of times that you've given to the right hand side, so your right operand is going to tell you how many times you want to shift your binary point. So in this case, you have 1 0 in binary, 2 is 1 0, and you're left shifting it by 1, which means you're going to uh, place your binary point to the right by 1. So you'll have this decimal point move to the right, and this will give you the value of 4. If you right shifted it instead, it would check the binary point, and it will make it move to the left. So your binary point will go this way and your final output will be 1. Next comes compound operators. These are basically shorthand notations. So plus plus is going to be the same as plus equal to 1, and minus minus is going to be minus equal to 1, with the operator present over here, operand present to the left. It could also be present to the right. That just tells us that how exactly the process is going to go. So if in case we have a plus plus, it's going to first display the value of a and then going to assign a the value of a plus 1. And if I have plus plus a, it's going to first assign the value of a as a plus 1 and then going to display it. So that's about compound operators. That's about operators in general. Now, all the code that you write down, it's going to be in any of these functions. So now that we have understand operators, let's understand conditional statements in a little more detail. So if else statements are conditional statements, and say if I want to add an extra condition, like if I have more than one conditions, I can use another statement called as else if. So in this case, let's say if the direction was ever equal to 0, then I would execute this particular code which falls under these curly braces. So if it's just a one line code, I wouldn't need curly braces. That's what we did here. And if there are more than one codes, like more than one lines of code, then we'll add curly braces and we'll put in our code in that. So that part, that piece of code is going to get executed if this particular condition is true. So that's about conditional statements. Now let's go up and understand more about looping statements. So we have mainly two kinds of loops that we'll come across quite frequently, the while loop and the for loop. They both have three basic requirements. First is the initialization, second the condition, and third is the increment or decrement, which would help us finally reach our condition. So it's the same thing in for loop as well. So you have initialization, condition, and increment, decrement. Obviously, there's another part, that's the code, which gets executed each time the initialization, or rather each time the condition is satisfied, until the initialized value reaches your condition. So there's a basic difference between for loop and while loop. So in for loop, you need to know the exact condition for termination, while in the while loop, the condition can, so you needn't know the exact point, but you would have to give a condition. So let's understand this with an example. Let's head over to our setup, because we just want our code to run once. We're going to take that to our advantage and have an integer value a, and have, okay, that can't be an integer value because it's exceeding the range. So let's say this is our integer value, and I want to count the number of digits in this integer value. So for that, I'm going to have my condition as while a not equal to 0, and then I'm going to use my compound operator a divided equal to 10, and I'm going to count. So I need a counter for it. So let's just call it ctr equal to 0, and this count gets incremented each time a is going to get divided by 10. So I'm going to go ctr plus plus. So finally ctr is going to contain the number of digits present in this variable, and I'll serial dot print ln the value of ctr. So you might have guessed how this works. You have this 5-digit number gets divided by 10 each time, and so long, and proceeds to count the number of digits simultaneously. And that's what we are printing over here. Now we can't do the same thing with for loop, because in for loop your condition won't be this. Your condition will have to be a fixed value. So say for example, I'm going to give a countdown from 5 to 1, say 0. So like I'm going to have I equal to 5, I greater than equal to 0 is my condition, and I minus minus is my decrement in this case. And I want to serial dot print ln the value of I. So in this case, you notice you have a fixed condition that we are giving, and we're decrementing it each time. So that's similar to this, but the condition is where the while loop and for loop differs. Now let's execute this code and see how it works. So it's done uploading. Now we'll go and open our serial monitor. So as you can see over here, the first one, that's 5, is the number of digits in the variable that we made, and the rest of it is the countdown that's from the loop. from 5 to 0. So this is the end of the video. If you have any doubts, you could leave them in the comment section below. We'll answer them. If you have any topics that you're not clear with, you could mention that in the comments as well, and we'll take it up in the upcoming videos. Also, I've mentioned the link in the description to the codes that I've used in this video. So that's it for this video then. Thank you.